OBS is giving me some trouble. Again, I'm doing this stream from a work computer, so my ability to do things on this machine is a little bit streaming issues is eventually. For a recap today, the last time we started to talk about, for this, run certain blocks of code that we're checking on the basis of really usually data number is greater than or if it's true, then we can run some code. General idea here, we're writing code that is dynamic in the sense that it changes based on these conditions. As we'll jump over to the text editor here. Python has 3 conditional keywords. We have if, we have to example, we'll do something simple. So we have some piece of data, we'll just call it A, which is going to be equal to 5, and B we'll say is equal to 7. And we're just baking in these values for here, but you can imagine that conditions in here. There we go. And then we'll print A. And we'll print A if 5. We can say A minus equals 1. And just to be clear, like operations can do something there. So, and then I could say if A is less than B, conditions, and all these each individual blocks. So we'll say that we have 3 conditional blocks, or excuse me, these 3 chains that if this one is true, it's still going to check, the Python interpreter is still going to check the next condition and influence the checking of any successive ones. And that's because these all start with if, right? So these all, an if always starts. So a conditional chain would be only one link in the chain. In one of the links will be executed, then the else will execute. So A is we can say elif. A is less than. We can print A is less than B. A is equal to 5 is equal. Else is going to have, it's just going to execute when all the other conditions were false, then the else code will execute. So we can say print, to quote that, there we go. Okay, so let's go ahead and run that. Let's actually comment this part. As you might expect, A is equal to 5, B is equal to 7. You might expect that since 5 is less than 7, which is not going to happen. So notice, even though both of these conditions are true, we checked if A is less than B. And the reason that one executes in the other, as the way they're linked means that only one of the bodies of code will be executed. And so the Python interpret is less than B. And then it doesn't even bother checking line 197 or 199. If both of these conditions ended up being false, though, line 199's code would exit, right? So the else. Cool. All right, so that's conditions in a nutshell. it just occurred to me, I know that this can see, you can think about it and you want to do something enough. If none of that ended up being true, then in all other scenarios, just do this instead. So there are cases when you want to, if you're just thinking about it in those terms, are there multiple things that I could do, but I only want to do one of them, then you chain together using if and elif and else. Cool. Oh, and an else always terminates the chain. So an else is always the end of the chain. I was doing recap, but really I was doing talking about this lesson. But let's look through it anyway. So the goals of this are going to be able to describe the conditional keywords and how they work together, use and understand if, elif, and else to write code. The example below of a common case from if and else. So it says num equals an integer of this input, where we enter a number and we see if the number is less than 30, etc. So this is basically the same thing, except instead of num, I'm using a and b and just checking a and b against each other. So yeah, this is a good point. And I didn't show this form, but this is something that you do common, where you check one condition. This is something that you do commonly, where you check one condition with an if, and then if that's not true, then you do an else after it. So that's a common thing. This block appears to have no condition, so it's not valid to write something that's like if a less than b, b greater than or equal to b. This would be invalid code. And notice it actually breaks my syntax highlighting, because the parser in my text editor knows that this is invalid code, and it doesn't know how to highlight it correctly because it's not set up to do that. So else is just always left bare like this, else pass. Excuse me, gosh. Something in my eye. I think I got an eyelash in my eye. It's a little deeper. So we can check. So conditions, like actually writing conditions, ends up being something. I mean, this is something that's very important. It's something that you'll condition. So let's just look at this. Instead of doing input, I'm just going to do. We'll just put in a number. Num is equal to 10, resolves to true. Elif, num is greater than 20 and num is less than 50. So this is a little bit of a different condition. We have talked about all these operators to this point, but let's look at what's going on here. So here, on each side of the and would be a valid condition all by itself, but we only want to execute this code if both of these are true, right? Elif, and you say elif, let's say num greater than 20, and then you say if you don't have any, you're not doing anything outside of the nested if, you can just delete the beginning of the second condition. Oops. And so this and is the same as having like an immediate nest. It's a little different if you wanted to do also. So, which is a valid, then this greater condition will itself. We can say if num equals 60, we can do something special here, and then else, this just says all of the prior conditions resolve to false. Not preceded by an if or an elif. The way this is working. So we have the end of a conditional chain, which, or an else terminates a chain, an elif conditions with an elif, because there's nothing to, it would just be an if, right? Because there's nothing to have been false before it for it to be the else of, so this is just kind of hanging out in the middle of nowhere without an if to have preceded it. So in this case, if this is all you wanted to do, you could just delete the EL in front of the elif and just make it into a regular condition, or a regular F. Excuse me. I don't know where my words are today. You can make it if in front of it somewhere, or above it, I mean, between the num and the elif itself, and the if. An elif, or whenever you see an if that is necessarily the start of a new chain of conditions. An else always following an else, because again it has no if or elif in front of it to, common to nest conditional statements. I just showed you one way in here to kind of like reduce that in certain cases. You don't want to avoid it like the plague, but if you can avoid it, it's to nest and it's just fine. Have no special interactions with the conditions that contain them. So if I have a nested condition, it's just for elif or else. So they are regarded the same way as any other arbitrary code within the body of the if statement, and must abide by the same limitations within only their own scope. Cool. So here we have num equals, and then I'll print that off. In case num is already less than or equal to 10, this condition was true, so the other ones won't be checked. But if, let's say if num was equal to like 15 or something, true, then we could say num plus, say num started out as so, and they're just, the same as any other arbitrary code. So they don't interact in any special way with the conditions that they're. Cool. So using if, elif, else structures to make a menu, you can have as many of these as you want. Explain all this code, but let's just which will be the result of an input. We're just taking the string from this input. It says choose a food item, burrito, pizza, which is S. So we have if menu choice is another question, we can do another input and we can say choose what kind of burrito you want, bean and cheese, which is A, or breakfast, which is B. Elif menu choice equals B, print you'll get a breakfast burrito. Else, if the input was not A or B, we'll say, and it just follows suit from there. So you can see we have sort of a first tier menu choice, and then for that choice we get to choose what kind of burrito or what kind of do what it does. Oh, I didn't save it. Okay, so choose a food item, burrito, pizza, or a sandwich. I think I like a sandwich. So this is the world's. Let me get a cheese pizza. So I'll get a cheese pizza. Now with 3 menu items and 2 choices for each menu item. Okay. This is this is almost useful, like you can, up to this point we haven't even covered that much, but you can start like being creative and actually start writing dynamic code. Cool. So this one says write a function. Here, I'll just copy this in. Oops. And we'll return true. Return true. If that number is less than or equal to neither. Whoever's writing this is exerting some effort to not just write the problem statement as the code, right? because this is pretty straightforward. So we'll say 5 or 3. So we'll def 5 or 3 takes in a number. We'll call it n. And we can do this. We can say if num, we'll do it the simple way. If num equals 5, return true. And we can say if num oh, I'm just being silly at this point. I'm trying to push a boulder up a hill. So if it's neither of these, we can just say else return false. Cool. All right, so let's see if that's going to work. There's a few ways to do this. This will be valid code. Oh, it's not. All right. Num is not defined. Oh, look at that. I took in n and then I called it num. I'll call it num in here. Do I? Super not even valid code. Super not valid code. Okay. I changed it in my text editor, but not in the actual. Okay, that's just me. All right. Cool. All right, cool. So that's one way to do it. Another way to do it, and I think we could clean this up a little bit for end of it. So if these were both false, then it's just going to move on and execute the next block of code. So let's try that out. Else return false. So this would be valid, and this is a nice complete little chain. Reads pretty well. You don't even need it. So I can save myself actually 2 whole lines of code here, which is not necessarily always better, but I can say if num equals 5 or num equals 3, then I can return true. So I can use this or to combine those 2 conditions and say under either of these circumstances, if that statement ends up being false, then it won't return true and it'll move on and it'll return false. But I could put an else here. I was going to do this in there because I want to just do that. We can say or this. The way to do this really is like this, though. Since our function just wants us to return true or false, then we can actually just return the condition itself, right? Since we determined that we can use this condition here, return true, that we want the function to return. So we can actually do, what I would encourage you to do as you're writing code. So we just did a little bit of an optimization, right? We started out and then we ended up with something that was a little cleaner and optimized. What I would suggest, I think there's a better way of doing this, and they won't do anything until they're certain that they've like invented this way of doing it or some other better way of doing it. If you to get code, then great. If that's not like the first thing, any of these, would be like acceptable ways to solve this problem. Although I would say that this last one is kind of cleaner, in my opinion. So, all right, let's do another one. Oh, and that's funny. The example one has the if, elif, and else. Okay, so write a function that says is divisible by which takes 3 parameters num divisor 1 and divisor. So parameters or both. It returns the following strings as appropriate. Okay, so these ones, the functions that return are here. Let me delete it. Right. Oh, okay. This is just telling us about us f strings. Gives us some examples. Go ahead and copy code as we go, and that'll be nice. So this first one should return numbers divisible by 3. So we can say if, and we want to discern whether mod divisor 0. And let me, I'm gonna intentionally make a mistake here. Okay. I'm intentionally making a mistake here. Oops. Not that mistake though. Okay. See if you can, and I'm going to keep the mistake. And they were really clear, you get used to them. So this, cool. And then we'll say if num, we'll say elif divisor 1 divisor 2 equals 0 also, and if it's not, okay, I just realized another thing. This number is, oops, not 1. So so if we look at this, let's just take it from the top. Let's pretend like I submitted this code and it's not working. Then it's gonna print this out, and it's not gonna, since these are elifs, it's not gonna check any of the rest of these, right? It's done checking, it's done running code in here. This first one is true, which means if it's divisible by divisor 1, it's never going to run because it's behind two conditions that it's sort of relying on, right? So if it's not divisible by if it's divisible by both, then the first one, 2, and if it's not divisible, then the alpha. So let's see what this does. This is going to give me a problem. Okay. Oh, is this supposed to return? Of course it's supposed to return. Here, and I kind of read errors from the bottom up. It says it failed. I kind of know that because the error thing, right? Ran a test, and it says assertion error, and I look for this sort of thing, right? It says none is not equal to this number is divisible by 3. So I know it turns. So now we're returning. Okay, so that was another mistake that I made in earnest. But see, what's like, getting good at programming doesn't mean you never make mistakes. It means you catch them. You catch your errors quickly. You know how to deal with your errors. It's more about that than never making mistakes. Okay, so check it out. This is the one. Finally, the problem I was intending to create. So this error tells us what's going on, right? So it says this number. So the minus means not this, and the plus means it is expecting this, right? So this number is divisible by 3 is not correct, but it's expecting this number is divisible by 3, right? And better formatted this well. This one is a little hard to read. sorry. These strings better match exactly. And you have to think about that when you're testing. So there's sort of, this is realistic. Like when a test is, it has to be character for character. It has to be, the second one it ends in a period, and the first one lacks that period. So we have to put a period. Oh, hello. All right. There's another one. And that's fine. I mean, I'm not saying that to like shame anybody. Like that's a very feasible mistake to make. But remember, strings, a single parameter, return something. I don't know what yet. Which is short for object. String object. If the object is an int, the function will return 0 if the object is 0. Notice the function will return the string 0, right? So I can just go through this now. So if the object is an int, so how do I tell if the object is an int? So if, and I want to be able to determine int, I know I'm going to want to return the string, 0 with a capital Z. If this were the number 0, right? Or if it were a lowercase z. All right. So if the object is an int, the function will return the string 0 if object equals 0. So so I have to return this actually under another condition, but first I have to write this. So how do I tell if object is an integer? So I can say if type. Here I'm using a type specifier. It might just look like I'm using a variable called int. This is actually a built-in keyword in Python, and it is. That you can do is you can say if the type want to check against, you can say it's just useful to just represent it as the sort of neutral form, which is 0. So 0 is an integer, 0.0 is a float. They are different. That's a neat trick. If you don't have the type specifiers memorized yet, you can get by on this. Okay, so if I want to see if of that integer, if it's even. Okay, so now we need to see, so our next goal is to return object squared. If is even. So how do we determine if it's even? It'll be j as an even number. That'll be modulo. So if the remainder of obj over 2 or obj mod 2 equals, we're going to do something if obj mod 2, if it's odd, now 2 equals 1. So notice I just consecutive ifs. These three can only be one of these things, only match one of these patterns. And also, since we're returning, I can make this a little cleaner by putting in elifs. I think I could actually put an else here, but I'm going to leave it as an elif because the problem statement explicitly stated this case, and it just makes sense to me to keep that reflected in my code. So even though this is actually exhaustive, this is logically equivalent because of the condition that I'm checking. It's going to have the float. So function will obj. And same sort of thing here. So since we have these, it's going to this is, we're saying only one of f type obj a float. Obj is an int, obj is even, obj is odd. Obj is a float. Okay, cool. Good. So that's float. And we need to do string and bool and then, okay. So we can just pass in an empty string. Obj, oops. So that'll be, which is true. Okay. And then we have our else. If obj is not one of the above data types, return none, right? It's going to return none anyways. But again, for the sake of like maintaining parity of readability between my code and the problem statement, the original problem statement, see how it's broken. Oh. Has no attribute, depends on type. I probably misspelled. Oh yeah, okay, so I wrote the name of the function wrong. So says attribution error module main has no attribute, depends on the type. So I see something that's close to the name of the function and says it doesn't have. We'll see if I got that right now. Yay, okay. Let's see what their code is. It's probably, yeah, okay, so they're using type specifiers and doing things in a little bit of a different order. But this is basically the same code. Okay, so the first thing that they actually do is check if it's a string. So they say if type obj is equal to memorized, but type of the object is equal to type of, it's going to give you the same string, but I don't know if the object times 2, but I went with a more traditional concatenation with obj plus the obj. So all the odd numbers and returning the cube. So we can use it to, what seemed simpler is just to return a different way to return of none as well. Cool.